Hello everybody, welcome to another stream. How are we all doing? So, last stream we got ourselves in a bit of a pickle because there's a very strange bug that was happening and left me a bit bamboozled with what the hell was going on. But I spent a little bit of time off stream doing some debugging and got a bit further with it. But then I looked around and I think I found the problem. So I think I'll start by describing what I've done since then. So I made a shader. So what I want to do is launch. Wrong one. So I made a shader up here which debugs the MIP levels, and as you can see they're all red, which means infinity because that's the way I've made the debug. So this is the occlusion buffer, and it's all got infinity in there. Now, for some reason, when I was reading from it, it was giving us back zeros, like it was doing an out of bounds read, and it gave us a 0. But then I was looking at the logs because I can log from GPU shaders, and it's fine. It's correct. So here's an example. So here's something I got. I did these loads, and I loaded from 2116 at MIP5, and it gave me back a 0. Straight away after in the code, I did it with I hard coded it, okay, to be at 2116. This was all worked out dynamically. These are all hard coded, and it returns infinity like it should do. So that was really weird. So if I hard code it, it's fine. So what it leads me to believe is so what it leads me to believe is it's something to do with this, I think. This non-uniform resource index thing. So if you have an array of textures, like we do, right? In the behind the scenes, we have an array of textures, array of buffers, and stuff like this. And we index into that array to get the texture that we want. And this all happens behind the scenes in my compiler. So if I look at is occluded, this is the function I was writing out. This here is just an index. It's just a U32, right? Not to be confused by that. That could be this could be anything. This is just a U32. This whole type. It's just an index into one of these type of arrays. If you've written HLSL, it's like this, right? So behind the scenes, it loads from that. So basically, what this is doing is going into the array of all textures and then grabbing out the descriptor from there and then using that, right? But the compiler just does it for us. So we can just pass this around freely as if it's data and not have to worry about, inlining every function and figuring out where the original descriptor came from. So it's all kind of nice in that regard. The problem with this is, so let's write some HLSL like code. It's something like that, right? Anyway, it's the uint or whatever, right? So you get a texture back and then you use that textured or whatever, right? So the problem is that so on GPUs, you have compute units which run in Wave 32 or Wave 64 mode on AMD, or just Wave 32. Basically, Wave 32 is compatible with every GPU. We default to Wave 32. Oh no, we only run on Wave 32. So that means 32 threads won't run in lockstep, right? And there's a rule in Vulkan and DirectX, and I think other graphics APIs as well, but there's a rule. But when you index into an array of descriptors, that index is uniform. It's automatically uniform across all threads within a wave, right? So this has to be the same value, and if it isn't, there's bugs. So I think what is happening here is because where this is called within this, and it runs 32 nodes across different threads, right? So we do 32 different nodes, meaning they could be in different places on the screen, meaning they would sample with different MIP levels, meaning they would sample with different textures, right? So that was my debug thing. So I think the problem is that we need to introduce basically, like HLSL has, but probably in a different way, a non-uniform resource index. That's what they have. I don't think we will have this construct. We might have something like this instead. Like a, like the word const, right? Like a type qualifier. We're going to probably add something like that. But there's another way to test this without adding that. One, I can hard code it, but two, there's a different thing I can. So I need to make a few changes in my compiler. I can avoid that non-uniform. So this thing comes with a performance penalty. That's why they have it. This non-uniform thing, because they have to output like slower code on GPUs. So to avoid that entirely, if I go to GLSL, there's a function called textall fetch, right? This is the thing we need. I kind of have this already, but I don't have the LOD parameter, and I need to add that in. So this will allow us to test to see if the problem I'm facing is this sort of like the fact that I need a non-uniform resource index, if you will, because I'm getting this texture index is going to be different across all threads, or it can be different across different threads within a wave, and therefore it's producing the bugs we're having where we sample from the texture inside a texture and it gives us back 0. So like it's out of bounds, which is weird. So let's modify the compiler, and then we're going to add, so let's go into HCC. There's, basically it's quite simple to add. There's a, in the intrinsics, there's a texture intrinsics. There's a fetch texture. So this one already works. Yeah, this one already exists in that, right? Where you can start. Like, but we need to extend its capabilities. And that is adding a uint32t MIP level. And that's what LOD means in the other APIs. Hello, hello. How you doing here? Not bad, not bad. I'm hoping, I don't know, been driven nuts by this bug basically. It's been crazy. Oh my boy. You might hear my boy next door is trying to go to sleep. I might look at him in a minute if he doesn't go to bed soon. But yeah, I've been alright. Last stream was quite tough because this bug was like defeating me. But I think we'll be able to defeat it and come out on top this stream. But yeah, other than that, I've been pretty good. That's been good. Did you get the GPU sawing to work? I wrote a version. Here's the funny thing. I was like, oh yeah, I'm not going to bother doing a... I'll just do a quick one. So I did a rudimentary sort of like... Well, okay. I did a very dumb version where I only used one thread. And then it was too slow. So then I had to sort of speed it up a bit. So I made this thing, which works and uses 32 threads at a time, and does a sort of kind of like an n squared complexity kind of algorithm. And it took me probably as much time as it would have just to port over the AMD Fidelity parallel sort thing, which I saw afterwards. So yeah, maybe I should just port this thing over. It uses a radix sort, and it's MIT licensed. And it can sort keys or a payload along with it, which is quite nice. So yeah, I think I might just port this at some point, and then I'll just have a general sort function. But yeah, that's how it went. So the stream after, we decided to take the depth buffer from the previous frame and just see what is the best case we could get from occlusion culling, and see if we can reproject that and start and use that as a metric to see what the best could be, and then see if we want to go this occlusion buffer route. But the icing on the cake would be using the occluders for when new objects pop into the scene and avoid some spikes. Right, so I've changed the function prototype here for fetch texture. Now in the compiler, I've just got to hop into the SpearB code gen and then go ham on that really. So fetch texture, load texture, address texture. For some reason I wrote code like this where it's super branchy and it shares very little code. But that's just the way things go sometimes. You just keep changing code and putting branches in everywhere when it could just be copy pasted into 3 different versions. So how are we going to improve this piece of code? We're going to add more branches. So I've added another parameter called MIP level, and I read the SpearB spec. For text image fetch, there's image operands, and I think I could do an explicit LOD. I've done this before. Explicit LOD. That one. Oh. Wait. No. Fetch. Yeah. LOD. Only valid for explicit LOD. What's an explicit LOD one? This must be it. I think this is it. I don't know what is an explicit LOD one. The way we can check is just see what we can see what HLSL does. Basically. That's always a good reference. So their texture 2D is our sample texture. And I've got to turn on the lights, isn't it? Thank you, Rosmusco. Appreciate it, sir. Fading away. How's it going, Rosmusco? Good to see you. Nice. Would love if at some point did recap stream, like going over the engine, showing off how stuff works. It would be helpful for people to find out about you, i.e. me. Yeah, and it is something that I'm really itching to do. Part of me is thinking, see, ideally where I would like to get is like, I end the stream at a time, then I record myself and just be like, this is what we did this stream, and go into little bits of detail and recap maybe every stream. And then somehow upload that to YouTube really quick, right? That's where I'd like to get to. I've also got a backlog of things to recap on, which I can do, but I just need to find a free Saturday to get it done. I still have time off. Work I could take, but it's gonna last me till the end of the year, and we're gonna go 8 days. So I'm saving that. But wait, yeah, unfortunately I was busy over Easter and I couldn't get it done. There's just, yeah. Maybe there's a holiday soon that'll pop up. But I want to. I recently just got like a new big ass wardrobe I got to build. So yeah, time is definitely a difficult one. But what I'm trying to do basically is find the time to do some form of recap on what I have and just brush because the last video I did I think it was a while ago. I talked about I just got the project structure in for the whole for the thing. Did the GPU system, had a bit of the OS and core and that. So it was before the UI, before graphics. Um, so yeah, it would be good to recap on where we're at, and then maybe do some kind of like regular recapping thing. Because it would be good because people really don't are missing a lot of context, and I have to describe a lot of the context every time I come on, which I'm not fussed with, but it would just be easier just to be like, if you want to know anything else, then send to a link of watching this 5-minute video or whatever. You could do a summarize up. You could up afterwards. Yeah, that's another way. Yeah, and then yeah, I think you can do stuff on Twitch as well, where you can mark it to be something separate, and maybe you can export it. Because in Twitch you can export it to YouTube, and that's what I do. But maybe there's a way. I'll look into see if there's stuff you can do, and maybe I can sort of cut the recording in Twitch, and then just do that. And the problem is I don't want to send it to the VOD channel, but maybe I can download it and then re-upload it to YouTube because it'd be so small. But yeah, I need to look into doing that. But yeah. So HLSL's texture 2D is the same as our sample texture. Not our texture 2D, but sample texture 2D. Because our texture 2Ds are storage textures, and there's a difference called a sample texture. Sample texture you can read it, you can sample and fetch. And this translates to a fetch. For crying out loud. Oh. Wait a minute. No. I'm confused. HLSL texture 2D load. Because that one allows you to get the MIP in there, doesn't it? Oh no, it's a sample. Wait. Oh, it's a uint3. Last component's a MIP. Yep. Yeah, I do know my HLSL. Kinda. Oh, graphics programming. It is so strange. Right. So what do? Image fetch, LOD. So they do use the LOD parameter. That's what I'm looking for, right? And they put the LOD in there. Okay. Easy. So we're just going to do that. So that's how I can know if it works, because someone else has done it. So we'll put the LOD thing in there. Right. So extra parameters. Oh. Plus plus if the AML operation is equal to AML op fetch texture. Maybe it should be called fetch texel, but whatever. One of them. One of those. Times 2. How many How many? Yeah, 2 operands you need. Excellent. Oh wait, it's a boolean, so you got to do this. Right. So extra operands, we add those on. Right. Yeah, so I think we'll do something like I is a really terrible name. Insert index, we'll do that. I like to use that a lot though, that name, but anyway. Wait, you can't select MIPS. Multi-sample can't have MIPS, can it? Yeah, multi-sampled cannot have MIPS. Excellent. So you don't need to do this fancy crap. Oh yeah, incredible. So multi-sample. No, sorry, what we're talking about. LOD, right? Which was another word for MIP. Now I need to get the need to get the right operand. So 0 is the return, 1 is the first operand, 2 is the second, third operand. So it is okay to hard code. Oh, hard code 4 and 5 since multi-sampled textures do not have MIP maps. MIPS. Boom. So this should be a way for us now to test out. It's going to break the one of the samples, but no worries. I can just come in here and just put a 0 in there. Boom. Run that. Oh, text will fetch. Blah 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 was undefined. All right, we'll look into that. I've messed up something. Oh, data type. No. Convert operand. Yeah, convert to SPIV. Oh, what are you doing? I need a W. I need a win. That's what I need. This means worker, by the way. Hey everyone, I think a summary video would make a lot of sense. Plus, putting on YouTube makes it available to get a different pool of potential viewers. That would drive engagement, really cool stuff. Yeah, definitely. That's another reason to do it. Because the project's getting to the point where there's now graphics and more visually pleasing stuff, which is always a good thing. But yeah, it's just finding the time, unfortunately. I need to just get it. I need to find a. I need. Would it be great if I get it in a place with him if I can get it to a routine, if you will. But yeah, it's gonna be good when we move to doing that stuff. I'm learning quite a lot from your engine as I'm trying to get rid of C++ habits to do more C style. So thanks for being insightful or helpful. No worries. Glad to hear. Glad to hear. Yeah. Yeah, C++. It is a death trap. It starts with constructors, and then it ends with templates. I guess I don't know. It's quite bad. Okay. sorry, I ran the wrong thing. I wanted to run the samples application in my compiler. There's a second. Here it is. So one is so that's the fetch texel. Yeah. So it does work now, or still, which is great. So if I run the release script, so we get a nice fast compiler, because we don't want no slow compiler, right? So we hop into the build. I probably want to open up a new tab as well, a new window. Tabs are annoying. Third party, drop it in there and kabam. Then I want to grab this new file that we updated, the texture intrinsics, so the prototypes are correct and it doesn't do something crazy. Now, we've got that new thing in here. So remember, the bug that we think it is because we're getting a non-uniform resource index, but we're fixing the problem by changing it to a sample texture instead of a read-only texture, which is different, right? Because read-only texture is a storage texture. So if I did fetch texture instead, it's text coordinate, but now I can put the MIP in here. That's what we've just added. So what I need to do to get that to work is I need to say HCC sample texture now. And I need to change stuff CPU side as well, but we'll get there. That can go. Occlusion texture, that's what we're going to call it. Right, let me comment out this stuff here. Oh, yeah, no, I want the print statement. Because the print statement will tell me if there's anything wrong, because the occlusion texture is just cleared to infinity, so it's not going to have any occlusion in there. So if something fails, it's a failure of the code and not the and not like the data, right? What we're trying to test. So that's great. We'll just carry on with these improvements. So prepare, this is it. Oh shoot. Right, this is gonna be amazing. So CPU side, what has to change? We have to change it to use the actual full-on occlusion texture that got initialized, because this has all of the MIP levels in it, whereas the other ones were texture views, where they only had one MIP, and there were one texture for each MIP as a sub view into this full-on texture. And the other thing that has to change is this. We have to add a sample format as well. And what this does internally, there's a storage format and a sample format, is it makes a different descriptor. So there's one descriptor for sample textures and one descriptor for storage textures, because that's the way my game works. Yeah, it ends up being better that way, because then we can have a different sample format, whereas the storage format maps one-to-one to the underlying texel format, whereas the sample format, you can have some, it's designed to have some format conversion within the system of the shader system, if you will. So I could theoretically change this to that to that, and tell it to be a unorm, RGB unorm, right? And it will do that conversion for me when I fetch a texel, but we don't want that. Yeah. Right. So I think that is it. just gotta be careful here for the minute. Oh right, I didn't change this other line either. Right. So I'm hoping this is the fix. This is me hard coding it earlier, and that didn't have the problem because I was able to probably make it the same on every wave, every lane within a wave. Okay. So if we run this now, fingers crossed it works. I don't see any problems. I think we fixed it. So what was happening before, like this is okay, right? Ignore that. This, oh wait, we don't know if it's occluding yet. I gotta check. It probably is. So what's happening is, or what's happening before is, you know, these spheres. These are made out of spheres, by the way. They're in 4x4x4s, and that's a cluster. What's happening is we was doing this, and you're seeing whole clusters just be disappearing, and even sometimes like you just see a hole in the sphere, but you'll see the clusters because it's just the way it breaks apart is in clusters. Because some of the clusters are getting occluded when they shouldn't have been, but now we're not seeing it. So I think we've fixed the bug, and we're not seeing any printing either, right? Which means that the occlusion test. Wait, what does it mean? It means the occlusion test is not failing. Perfect. So what I did off stream as well, for those who weren't here, this up here is the occlusion texture. Red means infinity, because that's the way I've done the debugging. So I just made this debug shader, and I'll show you it. It just basically goes over and draws each MIP. So this is MIP. This is actually MIP 2, because I knew MIP 1 and 0 and 1 were fine. I just wanted to see the rest. This is MIP 3, 4, 5, 6, 7, 8, and 9 is there. It's like a pixel big. So, yeah. Sehr gut, as the Germans say. So, now I think we need to move on to, right. Now, let's plug in the depth buffer from the previous frame, and let's see how good the performance gets. So that's about 1.5 milliseconds to do that ray trace. And this is how long it takes to do all the LOD selection. So that does add up to something. And this is only one instance as well, you got to remember. So when you add more instances, this will be kind of long. But what's great with the occlusion is it'll be able to shorten this time, because you're checking if the cluster is occluded, and then if it is, you don't check any of the children. So that could explode out into tons of savings. Because it's an octree of children of octrees, right? And it goes down a few layers. And this ray tracer then will have less things. So, I do want to fix that non-uniform thing at some point, but maybe I'll do that off stream, because it's kind of not. So I'm glad this fixes the problem, but if we ever had a non-uniform resource index thing, this is a problem. So maybe I will do it off stream when I get the chance. And that's another thing I do when I have a spare moment is I just fix my little things in my compiler and improve that. So I got two things I need to add to a list then. 2 seconds. Non-uniform. I need to add that. I also need to add qualifier. Maybe I'll do like a HCC non-uniform. I don't know. Be a bit ugly, but oh well. Then I also need to add. I also need to then change mute only. I think I've called it. Probably to HC mute only, I guess. Just so they're consistent, because that's already a type qualifier I've added. I also need to add, and the reason why I did it like this is because under the hood it will map to __ HCC non-uniform. And then if the same code is used across different compilers for some reason, then yeah, it can be compiled out basically. What else did I want to add to the compiler? Oh yeah, I wanted to fix a switch statement, right? Fix switch BC MIP where condition is a constant. Right, it fails basically for some reason. It does a type comparison and it doesn't strip the const away, and it's like, it doesn't. Anyway, things. It's the way it is. And also check to see if switch is limited to ints. I think it is, but I don't know. So those things I want to check. But that is not for this stream. That is for off-stream Henry's to solve. But I'm glad we can move on from the silly bug because it is so bloody annoying. Right. So with this behind us, we can now feed the depth buffer from the previous frame into the occlusion texture. So remember I said I did that debug view of the occlusion texture. Debug render. Okay, this is it. This is all it is. We launch this full screen. Wait. We run this one for each MIP level, and we give in a texture view which for each MIP. Yeah, we basically get a texture view for each MIP. But you can load it in different ways, I guess. And essentially, depending on what. So we run this one for every MIP we want to render. We dispatch it 8 times, for instance. Let's just show the code for that. There's no confusion. So we just go over all the MIP levels there. We pass in like the dimensions of the biggest texture, and we launch it for every pixel along the MIP. So we need, every pixel for the MIP. And essentially we say whatever MIP we're selecting, do an offset. So the MIP 0 doesn't have an offset. MIP 1 offsets to the right, and all of them after 0 start at the right, and then essentially the Y is just adding all the previous Y's before it basically, and then the offsets. Yeah, we just sample from the, pretty easy to whack together. Then we just sample from the MIP, get the value, and in this special case, because I want to see if it's infinity, I make red infinity, green not infinity, so I can see if it's green, then it's a problem. Yeah, so I think what I want to change it to do now is instead just make it red, right? But we're going to do value divided by 1024. And so now we'll be able to see the depth in there. Okay, so we're going to be able to see this, which is really great. Make green 0. Now, we're taking the depth buffer from the previous frame, and we're just going to use that as the occlusion buffer. So we'll be able to check it. So it's called reproject, but I'll tell you a spoiler, it doesn't actually reproject at the moment, but it will do in the future if we go this route. Because there's problems if you do not reproject, and we'll see those as we run it. So all this does is take the depth buffer from the previous frame, copy it to MIP 0 in the occlusion texture, and then we've got a full MIP chain going up to 1 pixel where it gets downsampled, right? So we clear all the MIPs that are above MIP 0, right? We then probably want to do that ray trace any of those bigger occluders, because you might just make something appear on the screen, or something that is transparent is no longer transparent, or something like that, right? Those two edge cases. Those things should have some form of quick occlusion rendering to save you some time, because these volumes, they're pretty dense. They got a lot of stuff. So yeah, then we go over all the what is this? Oh, that's the debug render. Our friend, our buddy old pal. Then this is our down sample. We need to re-enable this. I disabled it just because I was debugging what was going on. This one propagates up. Oh, it up samples, then it down samples. Yep, that's the way it goes. Because we could have rendered the occluders into any of them, but we only need the down sample if we don't have that big occluders thing. Right, here we go. Yeah, so we upsample through the MIPS from one by one all the way to the biggest one, and then down from the biggest one to the best one. And here is the result. It's pretty laggy. We're getting stuff that fails now and it's printing, which is fine. We're seeing a depth value, which is great. But for some reason, I'm not. let me disable that. Was really dumb to keep that in because it's just going to tank our performance. Right. It is occluded. Right. So we just want to sample. What do we want to sample? So the thing is I don't think I'm seeing this ball. So first of all, it's missing its head. There's something really wrong with like the texture, but it is doing some culling, and you can see it's already having an effect, right? What is that? Well, it's 0.8 milliseconds, and I forgot what it was before now. These things escape me. But it was definitely higher than that. Wait a minute. Yeah, so say we're doing this full screen thing, we're like here or whatever. That is, yeah, 0.8 milliseconds, right? If we disable the occlusion culling, how do I do that? Do I just put true in here? That means it is occluded. If I put false, yeah, so it can't even render all those spheres because the tiles that they get binned into are just getting filled up. But this is running at nearly 2 milliseconds now. So we just saved a whole millisecond there, just on that one. So you're seeing how by culling these clusters at the back of the sphere, say, or even in the middle, this is really giving a big performance increase just by having this occlusion texture. So we've just got to get it right. So this is the occlusion texture up here. We can't see anything in there. I guess if I go further away, do we start seeing stuff in the middle? So it is doing stuff, I just can't see it. So I need to figure out why that is. Can I go to that debug viewing? Value is there. This was me debug rendering the UV in that. And just making sure it's all correct, right? So if we just view what I debugged here. This is something you can do to sort of debug, make sure your sample is correct, right? The Y goes down to green, the X goes down to red, obviously. And you're just sort of like, yeah, making sure your UV is correct. So anyway, I'm deleting that code now. This is confusing me. It was 1024 too much. I didn't think it was. That's half anyway. Am I pulling it in. Am I debug rendering it at the wrong point in the frame or something? Oh, it's before the damn upsampling and downsampling, so it's not even going into the lower MIPS. So let me just move that around. And as you go away, it's like getting filled with. It is increasing in performance to render apparently. Obviously, these threads in the middle of the screen are taking too long. But all right, but I'm not seeing. Right, crying out loud. I should be seeing something. Let me change the MIPS down to MIP 1. Let's debug render from MIP 1 and see if that's showing anything. It'd probably be nice, better to use a color map like Turbo. Do not know what you mean. Let's take a look. Turbo, an improved rainbow map color map for visualization. Bum bum bum. Whoa. Do people usually use black and white? These look nice. Inferno. Oh, so you're just mapping grayscale to... Right. I could add these as functions too, and I just sort of... Right. So I guess it's just got a bunch of code to get the color ramps for those. TLDR, TLDR. Find the color map data you said instructions. CPP? CPP. Oh, it's an actual color table. Right. So you're better off basically making that into a texture and sampling it. Or yeah, put it into an array on the GPU. I could just put that into my globals and let's see. That seems pretty algorithmic though. That increases by 3. That increases by 2. Oh no, but it's not. It's kinda. How do I run it? Algorithmic. Exactly. It did look algorithmic. Nice. Copyright Google. Excellent. Yeah, I can't copy that. I'm being recorded. Probably not a good idea. But I see your point. I can just make these. But yeah, it sounds like a good idea. Um, oh, it is there, isn't it? Hmm. It's under an Apache 2 though. Whatever that means. Hmm. I'll think about it. I'll leave it there. Thank you though. Wait, did I just close the wrong window? Apache 2. Yeah, isn't it basically like MIT? Can only show hold liable. Yeah, must be copyright license, state changes. Yeah. That's cool. I think I can put it in the attribution section and just put that in there. Yeah. Not a bad idea. Let's give it a go. So if I put it, I just will chuck it in somewhere. Documentation, attribution. Turbo color map. Apache 2. 2.0. Just drop the link in there. Right. That's good enough. Float. Gives you a float 3 back. Yeah, I might do a float 4 version. So with a map 3, we just get back as a raw color. What is... Oh yeah, X is the grayscale value, yep. Oh, good old const. Tasty. Right, so... Oh, those are vec2s. Right, and we don't support doubles. Well, we do support doubles, we just don't have them enabled. So we've got to F those things right up. If not, my compiler's like, you tried to double. But we'll want to float. Saturate, what does that mean? It just means clamp. So, but it means clamp explicitly with a 0 and a 1. Then, well, if I do the 4 version, then it means I can just XYZ it away, right? I got swizzling. So, yeah, take that. Oh, the swizzling. I got swizzling, but not operators. I don't know. I get to and from about operators all the time. To and from. Right, so what is this doing? Right, you need a dot. Someone who worked out this mess. Bless those souls. Bless those souls. Oh yeah, but I want to return a 1.f and make it a 4. Oh yeah. So I think that ought to be good enough, and we can try this turbo color map out. That'd be cool. Thank you. Thank you, Rosmosco. The man. Oh, I put it in the wrong damn place. So I need to put it somewhere, somewhere that makes sense. And right now, anywhere makes sense. Kinda. So we'll just, yeah, this file needs cleaning. But it's fine with trying to find our art style, so mess is the way. There's some order. it's not completely messy. So what Rasmusko is suggesting is if we do this. Instead now, use this sort of turbo color remap and then get back a lovely couleur. And then throw that out onto the screen. Oh, we're seeing the ball. Oh, we're seeing them in the lower MIPS. It's happening, Rasmusko. It's happening. I don't know if we're getting the right value or anything. I don't know what I... So let me, where's my MIP? Debug MIP. Debug render. Yeah. So let's pre-put this back. Oh. We're not debug. Hang on a minute. The high resolution maybe wasn't rendering that I was seeing from there, but let's view the lower ones first. Oh, something weird is going on. Ooh. That downsample isn't. Am I really only seeing it when it enters that area in the screen? What possessed code have I written to the point where I have to put it in that location in the screen for it to be shown? What possessed code have I written? I surprise myself sometimes. So maybe that reproject. You know what? Let's disable this debug render. We've got another one. It's good too, I swear. So we'll take this thing. We go to the end of the ray tracer. Here. So this is the end of the ray tracer, and this is what puts the pixel out to the screen. But sometimes we're like, nah. We have a depth, and this depth is not infinity. So because it's not infinity, I want to put another pixel out to the screen, which is actually the color, which is actually the depth value, right? And that's what I want to do. Am I using MIP0 and MIP1? Yeah, so the problem is MIP0 is actually bigger than the screen because I round up to the nearest power of 2. So the debug view is a bit... You would not be able to see the lower MIPS, so I started MIP1 instead, or 2, because they're small enough to fit on the screen, and I knew that the first two were okay. But now I don't know they're okay, so I'm using this view instead. So this will do it full screen instead, and we'll do MIP0. We'll start there. Why am I seeing black on the screen now? Well, maybe RenderDoc will be the tool for the job. Have a subsample in the MIP so you can see them all. Subsampling. Hey Katsumi, Katamoy. Hey, welcome back. What do you mean by subsampling the MIPS? I'm not sure what you mean by that. Because you can't view them all over the same overlaid, right? Right, occlusion texture, here's our boy. Right. Oh, it's down floating point, this is the problem. Can I put like a really high value in here? Holy moly. What have I done? Zero said undefined image. And a downsampled undefined image in that case. But it would have got written to... the UN. The problem is it's a float and I'm making it a UN. Maybe this wasn't the right tool for the job. Damn it. At least films at 2 for the screen. Read every other pixel and make it smaller on the screen. Okay. That sounds logical. I don't need to see every pixel, do I? That's a better idea. So let's change that instead. Right. So... how might we... should I introduce another parameter and that will be... I can change the scale. So... you read... so you can scale it, I guess. I should be able to pass in a scale. But it's kind of an inverse of a scale, I guess. But yeah, it will scale this offset. The sample offset. Maybe. So instead, let's pull this back to sensible, the world of sensible. That's the resolution of the texture now. That's one for the specific MIP. Then maybe we can introduce like a scale of some kind. Yeah. So maybe we should say scale source. And you can scale it by... see, I think I need to scale it by... maybe just 2. Because it's 2000, and then it'll make it 1000. Problem is, it rounds up to the nearest power of 2. And maybe... then the rest will be... yeah, maybe it's an... I don't know, it still might go over, but I've got safeguards in just in case. So what I can do then is I can divide this. I can divide the result by that. Hang on a minute. and then that would mean that we dispatch the correct number of groups, right? Because we have to divide that by 2 at the end. If we got, yeah. So then that would then mean we've got to add that scale source to there, and then the offset here is going to get the scale treatment. Molles scale source. So then that would then mean, what is that? The rest okay? Probably. If everything's on the screen. Yeah, let's be good enough. Let's try that. No. Yeah. Alright, let me do it by 4 times for a minute. Now the problem is the offset's no longer... Oh, that's offset. That's destination coordinate. Whoops. The wrong one. There we go. Kinda. So, I don't know if it's correct still. So, to make sure our viewer is correct, we're going to kind of revert back some of the changes a second, right? We're going to make this color isinf value, and then is not infinite on the. So if we get green, green bad. But we're mainly looking for red. And then what I want to do is disable a lot of what's going on. So put this back to here. We'll comment out this reproject the previous depth buffer. And we'll leave the propagate in, I think. Well, let's disable the propagate first. And then we'll re-enable that first to see if that's causing us problems. Alright, I'm seeing yellow. I was expecting to see either or there. What did I not I didn't not the result. Right, so it seems like everything's red. Right, so we've got a clear problem. We're not seeing the individual MIP levels. So I think the offset is still a bit buggered. Let's fix that. Need scale. Scale and offset based on the MIP. Oh, there's the offset, isn't there? Yeah, but sorry, that's the offset on the... Oh, right. Right, so MIP 0 is shrunk by 4. Ah, the dims. The dims need to be shrunk too. That's the problem. So what I want to get is probably a dims equals div s to bc dims bc scale source. Well, it's not already saying scale. Oh, whatever, I don't know. Yeah, it shouldn't be called scale source because it's not really scaling the source, is it? It's more like shrink. Inverse scale. It's a better name. Right. So if we use that instead. Boom. Right, let's try that out. Right, so we're getting 3 different ones there. That's a bit weird. Probably because the final MIP shouldn't really be shown. So what we should probably say is, so I guess we should say if dims, if any g equal g s g 0. So if any of them are equal to 0, then don't do it. I think that's kind of what is happening. No, okay, turns out I was wrong. um, no subsamples, smaller MIPS. Yeah. Hmm. But then yeah. I think I still need to, so they are consistently sized. Yeah, I could probably improve it though, so it doesn't do that at some point. But I just need to see if something's in there, I think. Yeah, because MIP 0 and 1 need to be positioned better, but yeah, I don't know. Hmm. Also, I wonder if it was a mistake going up to the power of 2 texture. Maybe it wasn't. I can look into that later. But yeah, I also need to debug the info. That's all I need to do. But yeah, so I think we're okay now. Although I'm not sure what the issue is. The lower MIP. Shift right MIP. Yeah. Have you got it bounds? Yeah, it should be fine. Yeah, I think let's try and plug this in now. See how that works. MIP was definitely simpler than what I see here. I'm not sure what you mean. Like, we're not doing anything like I'm not sure what you mean. Wait, it made the lower MIP levels for you? Is that what you're saying? Like, because we're not doing anything like touching Vulkan at all, so I don't know what you mean. Yeah, I don't want to enable the propagate, I want to enable the bring back the depth texture. Okay, so I didn't propagate. That's my problem. Oh, no, but I wanted to. Right, let's do the propagate first. I want to see if that messes up anything. That's what I wanted to do. This does the up sample and down sample. I want to see if that buggers anything up between the MIP levels. Right, it doesn't seem to be changing anything. So that's good. We keep that going. Now we get the depth buffer from the previous frame and put that in the occlusion buffer at MIP 0. Then we re-enable this color map thing. Okay, I didn't see it. Right, I cleared the texture, that's the problem. Where's the texture clear? This one. Clear the occlusion map to infinity. I was clearing MIP 0. I don't know, either I read MIP or I'm thinking MIP mapping. This is too much brain power for me. There we go. I see occlusion texture. So what we're seeing though, is we're seeing that effect within the occlusion, within the depth buffer, right? Yeah, so MIPs and MIP mapping are the same sort of thing. The thing is I think OpenGL, like MIP mapping is having the ability to create half resolution textures within the same texture, right? And then having a way to sample, it automatically sample between them, right? And stuff like that. It's kind of like a big, yeah, it's kind of got multiple things. But yeah, I think what you did is you made a texture. And I think in OpenGL you can call OpenGL generate MIP maps. And I think there's a way to call a function that does it. I don't know if there is a way to do that in Vulkan. I don't think there is. Maybe there's a library to do it. Yeah, so I think you just do it yourself basically in Vulkan, do a compute shader. And then you just copy that thing around between your projects. But yeah, it's stuff you have to write. It does seem simpler in... Yeah. It does seem simpler, correct. Right, excuse me. So I think we're seeing progress. My only problem... What the crap happened there? Ah. So this is... We are getting some out of bound writes. Like we can see. So this texture is power of 2, so it's actually bigger. Yeah, so it's a bit bigger. I did it because of the MIP mapping, but I don't know if it is a good idea. Maybe it is. But anyway. So what's causing this glitch here now? So it's checking in the occlusion texture if it should be rendered. If it's occluded. And it's saying yes it is. I think it's checking the bottom of the page. It's checking the opposite end of the texture, I think. I have a feeling it's checking the opposite end of the texture or something like that. It's not quite reading the right spot because it's a bit bigger than the... Yeah, I don't know if that's a bad idea or not. There's power of 2 dimensions. It might just mean we have to be special when we do the downsample. Like, if... I think there's gotta be a... I don't know, something just feels a bit off about... Because at the end of the day, you're just gonna sample... Like, if you go out of bounds with your sample, you're gonna sample, like, an infinity value. If you're going to the edge of the screen, I guess. Yeah, I'm not sure what to do exactly. But yeah, I think... maybe... So if I make my bitmaps non-power of 2, is that a problem? Yeah, I think the issue is I'm calculating the wrong UV, basically. Because I think I flipped the y coordinate in some cases, and I'm grabbing the wrong end, and then it's cutting off. Like when you're seeing this cut, what you're probably seeing is that that height is probably the height of that bit at the bottom there, I think. It looks like it. I don't know, or that could be at the bottom, I'm not sure. I have no idea. So I think it's a bit off, and I think it's because we're doing that damn power of 2 thing. I might undo that and just see. I don't know. Yeah, it seems alright, but then I just guess that UV is going to be a bit buggered. But there's going to be something to do with downsampling that's going to get a bit messed now. Maybe. But let's just run it and see how it goes. Alright, here we go. Right now nothing works. Excellent. So it's still got infinity in there or something. What did I just change? Yeah, I just deleted all those. shoot, I'll delete some code. Right, here we go, occlusion. Right, so the occlusion in the previous frame. Let's... Right, why is that not saying 1 there? That should say 1 there. That's the issue. That's the reason why it's broke. Perfect. Right. So why am I seeing it as a power... Right, this is fine now. Where's that debug render code? Here. That resolution looks a bit messed. I'll think about upping my resolution as well at some point. Yeah, that resolution is definitely looking a bit messed up. You can add special cases to color map before infinity. Magenta, brown, grey, white are available. There's already it's already looking brown anyway. It's like orange. That's a good point. Now, what's it called again? Turbo. So what he's saying is if infinity. Magenta is a mix of red and blue in it, so we can just do red, green, blue, alpha, and that should be right. Not a bad idea, Rasmusko. So why am I seeing in this debug render MIPS now? What have I done to... What is the pale brown? I don't know. Well, it's gone now because we've put the infinity. Wait, you mean this background color here? You mean this one, this gray? I don't know what this is. Because you've seen my screen resolution. It's kind of square, right? And this ain't square, and this ball disappears off halfway down the screen. So something is super fishy about that. I'll tell you that now. I can tell you that now. It's kind of 960, so... Yeah, I don't know what that is. What have I done which is so dumb? I can do the UV thing. Maybe it's sampling out of bounds. It is timesing it by 2. Maybe it's some. You know, let's make that scale because I've got safeguard code in there. Blend point exception. Oops. 1. That's what I mean. Right. So it's in the full screen. Then only shows there. What is my depth texture? Width and height. It's alright. How am I launching my copy? Reproject. Yeah, screen dimensions, that's alright. Load depth texture. Door. Seems alright. Let's do that UV thing again. The UV trick I did. Let's color the MIPS out. So destination. This is probably the source offset. Source coordinate. So we take the source coordinate dot x divided by nowadays, where is it at? dims.x shift right MIP. I think that'll do it. And we'll Y it. I'll comment this one out instead rather than deleting it. This will just give us a UV as a color basically. Well, not really UV, but pixel coordinate as a color. Oh. Well, that got messed up. One needs to be made of float. Integer truncation. Alright. So that is correct. So the whole screen is going across. So if I bring that down, increase that scale thing, so it shrinks the MIP viewer. Yeah, so that's all correct. So the UV is fine. And what we're grabbing out from the texture is also fine. The problem is coming from the actual texture data. Is it my propagate code that's messing up? So, oh, that's starting from 1. Hey, is it right? Yeah. Whoops, why does that say 1 there? That shouldn't say 1, so it's not grabbing the code. What? Still though. Yeah, it's missing the 1. Yeah, that's not. It was missing if you wrote anything to the 1 by 1 by 1. MIP. Hey VMT, I just woke up. What? 11? Pretty good. Did you fix the indexing bug? Was it? Yeah, it was. It was that exactly. All right, so we are getting it. It does show up in the It is my downsampling code that's now buggered up. That's good. Alright, we can look into that. Also, you can tell some of these are grey here. That's not good. So the way I got around the problem, so I didn't add anything new to what I changed the function prototype of fetch texture. Yes, this problem was really annoying. I was accessing a different texture in different threads on the same wave that run in lockstep, and that's a no-go. You have to use that sort of non-uniform resource index in HLSL, which I don't have just yet. So I need to still add this to the compiler. For cases where I do this, we have an array of textures which we have in the background, and this index can be different across each thread within the same SIMD wave. So we need to be able to mark a variable as non-uniform, basically. And it does generate slower code in the compiler. So I wanted to avoid that as well. And luckily, if you use a sample texture and you use fetch texture, you can actually pass the MIP level in there, and you're using the single texture which has all of the full MIP chain in it. And the only time you can't do that is when you store to it. If you store to a texture, you have to you have to use individual textures which are a view into the bigger texture for one for each MIP. But yeah, so this has been the workaround, which is great. I've added a note in my to-do list to add that non-uniform thing to the compiler, because I probably am going to need it at some point. But maybe I'll just do it when I need it, I don't know. But it's there as a to-do for the next version of the compiler. But yeah, why was you asleep? Did you take the day off then? Or did you have a nap? Yeah. It will bite me later. I'll be like, yeah. So my propagate code is buggering it up. What about doing an upsample from the low to the highs? Is that buggering it up? Yes. So the reason why this happens is because we've not got a perfect power of 2 size anymore. What we saw, right, is the clear is not really clearing everything correctly. See here, this is grey at the bottom, that's grey to the right, and stuff like that, the lower MIPS. And that's because it's not power of 2 anymore. So these will go down to a power of 2 when you... Well, not really a power 2, but... So I might look at RenderDoc to get the correct values. But... So when I do this clear... What do I want to do? Yeah, I had a doctor's appointment about 8:30. I fell asleep around 3 last night. I have a North America client work on the back burner. Came home, did some work, felt sluggish, and went to bed. Wow. Wow. Crazy. Seems like you needed it, that's for sure. Sounds like you must have been so tired. Basically did a 24-hour day, right? And you worked at the end of it, that's nuts. How am I clearing these? Right, so it goes out of bounds on the dims. So how do we get the correct dim now? So I'm going to open up RenderDoc and I'm going to see how we can get the right dim. Now we're not doing that power of 2 thing. If it's an issue, we'll go back to power of 2 exercises. but I don't know yet. So we can open it up. It doesn't have to worry about being correct, it's fine. I just need to find where we use it. Right, occlusion texture, here it is. So there's our resolution, half, 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 half. But as it gets lower, an odd number appears out of nowhere. So those probably need to get rounded up. Wait. So you would half that. It would go to 15. 15's fine. Then you would half 15. It would go to 7. Wouldn't it? Wait, okay, let me right. 960, sorry. Shift right. 6. We get 15. So why isn't it writing to those MIPS? Is it the problem lower? Right, 7, yep, it's good. So we did 7, shift right 1. We got 3. Seems like the logic just works out fine, it's just shifting right. Except when you get to 10, I guess, but still. It's just halving it all the way. It seems alright. So summing up with my... Wait, it's not the clearing. That's the fault. I just realized it's not the clearing, is it? I remember now. Oh, no, it's the clearing. What am I talking about? We can see it's here. That's MIP 0, 1, 2, 3. MIP 3 is that... So what's MIP 3? 120. Looks fine there. Oh, probably because I skipped the... No, it can't be because I skipped the pixel. Could it be because the debug draw thing is a bit weird? Let's put the scale in a 1. Take 1, start on 1. Manjaro is amazing. Getting advertisers now, Manjaro. Crying out loud, what did I do wrong? Yeah, I did something wrong there where I'm landing the viewer. MIP 0. I need to offset that texture in it. Right, I don't know what I've done now. I was trying to start from 1 instead of 0, but that's not happening. By the way, have you used the RenderDoc API within the application? It's pretty nifty. You can trigger capture from the application, game logic, whatever. Yeah, I've seen that. I've not hooked it yet. Hooked it in. But yeah, I've seen that you can do that. Yeah, the problem is with RenderDoc is it's not always correct for my game. I don't know what I've done. And I don't really have a problem with just triggering it manually yet. But I guess if when I get more of a game and I have like I'm I'm deep in within a state of the game or whatever, maybe it is better to integrate it. I don't think it's changing anything when starting from 1. Maybe I don't. No, the only problem is the it doesn't become the biggest one. Yeah, so I only get these that show up, and these don't become bigger now. Yeah, so I wanted to take away one. And then add something like that. Yeah, but now the sizes are off. I want to see these a bit bigger, you see. So then that'll be shift right 1, I think. There we go, I think that's right. And I change the scale down. I don't know what I did differently. Yeah, so someone did the scaling, I think, but I can't see the thing within there. Oh no, but it's because they're MIPS 1, 2, and 3. And that. And the propagating is, I've disabled that, isn't it? Oh, for crying out loud, it's too much stuff. Too much stuff. So if I enable the propagating now, we'll see it in some cut down version. Yeah, excellent. So we're seeing it with the bug. The bug. Right. So the problem isn't because there's a bit of oh, so yes, the problem isn't because there's like a little bit of grey at the edge, which is being there kind of is. It's because it's an odd number. It's grabbing a pixel out of bounds. It's because this is an odd number. Yeah, it's grabbing a pixel out of bounds or something like this. So all we need to do is we need to account for when they are not. Yeah. So how are we going to do that? So if you upsample, it's a 1 by 1. Doesn't necessarily mean there's always a pixel for you to get, basically. So that's not too bad to fix, I don't think. So let's look at the upsample code first. So yeah, it's just a macro. It just automatically does it. I sometimes use it, sometimes don't. I just forget because the code at work doesn't have it. But yeah, it's kind of handy. So it just maps to. Yeah, it just maps to something like this, where I automatically make that a U pointer. I can name the index whatever I want. I can start wherever I want. I can end wherever I want, and then it increments by 1. That's all it does. And it works in my shader code as well. So in the downsample code, upsample, that's what I meant. So you're going from low to high. So your source is low, your destination. So you're dispatching over every pixel in the destination. Okay. Which means you take a shared pixel. But sometimes you grab a bad value, is that right? 15 to 30. What would it be? No, because 3 would just grab 1. Um, Maybe we should capture and render doc and just view it. Probably a good idea. Run allow, what did it do now? Why isn't it rendering? The reproject, clear, downside. Did I not undo enough? Oh no, that's exactly what I wanted to see. Yes, exactly what I wanted. Whoops. So if pixel goes out of bounds because you can't get half value of 15, you get 7 instead. Yeah, it should be alright. It should down. It should just get 15. That should be fine. That's what I'm thinking. Yeah, you should post some more of your clips and your screenshots of your VR project for some semester ago. Wait, 7 to 15, you get 14. No, 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 wait. You got 15, you divide by 2, you get 7. You get 7, yeah? Why does it not show up in render doc? It renders differently, damn it. Let's see what it says in here then. Down is down sample. Propagate. So, what is 1 by 1 at this point? Right out loud, what is this? Alright, that's the full thing. Right, there's the 2 by 1. There's 2 by 1. 1 by 1. Oh, 0. That's bad. Right, there's the issue. So the problem is we're dispatching, we need to max 1 on that. Because what happens is we're shifting right. Yeah, okay. That's the problem. So when we do the clear, we shift right. But what we really need to do actually instead is max it. So we need to say max E32 max S1. So it needs to at least dispatch 1 no matter what. So we probably might have that issue for every time we do this. So anytime where we do whatever, you know, width, shift right, whatever, that is going to be a problem. So that is, even for that debug viewing thing, we need to do that. Okay, so I think that's where my logic was maybe going wrong with this, with these MIPS. It's quite easy, you just shift it right. But whenever you deal with the dimensions, you just gotta max it with 1. I think that's where I was going wrong this whole time. Okay, that seems sensible. You max it with 1 always. Shoot. Then it's gonna divide it still. Where do I want the max? You always want to launch something, and in the shader, debug render MIPS, when we do this on the here, we need to max S E32 times 2 and 1. And voila, I think that is everything we need. Patience. Damn it, Russell Musco. We need more. Okay. So turns out. Still not working. And why is this? Why have I got some visual? Like my spheres are rendering on my green screen. Look at that. Oh. Right, they're gone now. And they're back down this camera. So let's rerun that again and see what the same problem. Oh, it's going to do the divide 8. No, divide up. Yeah. Right, it's now rendering in render doc. Yes, I just said that. So we got a different problem then? Maybe there's a problem with the Right, here's the clears. Clears that one, that one, that one, that one, that one, that one, that one. Do that. Right. Next one. Okay, good. 8. 9 gets cleared. Good. 10 gets cleared. And that's it. They'll get cleared. Next one. They're cleared as ray trace, so we don't care about this one. Propagate up sample. So this one takes 2 textures. It takes this MIP level 10 and 9 and it up samples. So apparently that's fine. So basically what I want to do is go to the bottom of up sample. Oh, there's a problem there. Oh, so there's an issue. Okay. I need to go one by one then. Okay, so right, so MIP 9 is fine. MIP 3, however, no, MIP 3, MIP not 8 has a problem on both the X and the Y's. Bum bum bum. So it doesn't. So this pixel and this pixel, you see it down here. Oh, you can't see that actually. There's a window. Yeah, so this 1 pixel border is messed. So we're probably not running the pixel shader for this. Are we? 5 by 3. Alright, let's look at the logic. Up sample. So your destination MIPS are going to be that shift right by the destination is 8. So it should be 5 by 3, but we saw that was fine. So that will probably be right. And then your source is going to downsample by, well, it's going to shift right by 1 and shrink it. Min source dims. Probably right. You'll get 2 by 1. I think that's alright. But it's obviously not. Let's double check the values with the calculator. So your destination is obviously going to be shift right 8, 5, right? And it picks the maximum between 5 and 1. That's fine. Dispatch for every pixel over there. Okay. So if any of them are equal to the or more than equal, they go out of bounds, then we bail. How many are we launching in the thing? It's just 1 by 1s. Okay. The destination coordinate, we load that. We load the one in the destination. So before we did it, it was fine, right? But after we did it, it went to this. So we take the dispatch index, which will probably be so 0, 1, 2, 3, 4. 4 shift right. 1 would be 2. 2 goes out of bounds. 2 goes out of bound. Oh, no, it doesn't. 2 is fine. So it should grab 2. But then we min it with source dims. Ah, damn it. Wait. Should be fine. Source dims should be 2. We can check. By the power of RenderDoc. Here we are. So destination is 5.3. Source dims is 2.1. Right, that's good. So back to the texture viewer. So it was saying pick the minimum between that shift right 1. Should be alright. I might get my source and destination the wrong way around. Maybe. I don't know. So your source is the... Yeah, they're fine. That's the one at the back. Second from back. So I'll give you the higher resolution. It should just like truncate and just grab the right one. What am I doing wrong? Like they yeah, I don't know if I can run a shader debugger in here either. Forget. I know you can do it for pixel shaders and vertex shaders, but it's just compute. So we get that value, which is, well, it's not 4, it's 0 actually. Wait, why is it 0? No, 4, there you go. 4, yeah, 4, 1, okay, okay. Yeah, these are all looking correct. So I guess the first thing to do would be let's just output a value of infinity and see if it does anything. So run that in RenderDoc now. Let's see if we get the same result. So that's 513 on the event ID there. So it should be somewhere similar. 513, there we go. Extra viewer. Right, it says the 1 by 1. $58, $57. Wait, are these clears? What are these? Propagate up. Hey there, Wajilla, how you doing? Welcome, welcome. So these seem to be fine. So the destination appears fine, it's just the source. It's just the sources, you know? Just whatever we grab from that source pixel, it just seems off. Right, so I guess we can ask RenderDoc. We can actually look at close that one. RenderDoc can tell us what textures we actually grabbed. So maybe we're grabbing the wrong one. Good to hear, my friend. Yeah, we solved that bug we was encountering last time. So we're just trying to get the occlusion texture to be downsampled correctly. But yeah, things are going good. We're just gonna be doing some benchmarking soon, I think, to see how good the occlusion texture is. I'm probably actually going to test if it does occlusion culling properly. We're only occlusion culling clusters right now. 513. Okay, so this is on MIP 8. Yeah, it produces that border. There you go. So what we can do is we can go over to pipeline state. We can click here. Make sure you click on your stage correctly. So it's got the two MIPs here. MIP 9 and MIP 8. Seems correct. So yeah, it's the ones we were viewing. What am I doing that's so dumb? Source coordinate is destination coordinate. Scaled down. These are reading all the same. Like, that's not changing. And we get depth back. Like, should we do some printing and just double check it? Like, so let's do, like, we've got printing, so we can just do that. So the specific one I'm looking for is like, hey, if so I can't really get the exact. The way we can tell is if I can get the source texture, and if that's equal to 57, then I want to do a print. I want to print out all the values. I want to print out the source depths. So we're going to read from here, and then we're going to get back this value. So into destination, we'll say wait, why did I write source depth? Okay, so we're gonna put in dst chord.x.y, then we'll do a sort of a source coordinate, then we'll do a source depth. That'll be a good one. So if we run that, we should now be able to see all those values. So what we're getting is, yeah, we're getting a 0. It samples a 2, but it is a 2. Oh shoot. Sorry, oh my days, I was getting confused between indices and dimensions. Okay, so right now it's spelled out for me in English. Yeah, I can see the problem now. It's very obvious. So didn't we solve that problem though? Right, I need to min it with the -1 of that. That's the issue. Min it with okay. Whoopsie. Yay for printf. Okay, so that seems to solve the propagate backwards. Max chord 14 divided by 2 is 7, which is out of bounds. If size is 7. Yeah. I cannot believe I didn't think of that. Right. Okay, so now it's working fine. That's good. Excellent. Right. So getting some glitches here, but this texture used to have a grey outline. So that was in the propagate. I wonder if the propagate backwards still works correctly. Can we see the ball? We can see the ball, but the problem is I don't think the propagate backwards is maybe working near the edges. I don't know. Yeah, we are definitely seeing glitches. So maybe our sampling code is a bit wrong or something like that in the occlusion. So now we've got MIP0, which is here, MIP 1, 2, 3, 4, 5, 6, and whatever, and so on. So each cluster of 4x4x4 set of spheres is going to draw a bounding box, right? And then check how big that bounding box is and grab and shrink it down to the MIP level where that bounding box is 1 pixel, and then it samples from that. But I think it does it a little bit too liberally, if you will. So maybe this sample code needs to be looked into a bit. Maybe it doesn't. But the is occluded. I think we need to say like, because I think the problem, you can span over pixels. Happy No Engine Hundo? What's a hundo? Hey there. Sockham, how you doing? So I think the problem is, right, we can have this sort of bounding box which exists. So you have this bounding box, right? And if you scale it down to where this is 1 pixel, the size of this box is 1 pixel. The problem is, so you go to like a rough thing, right? The problem is now it's checking this box, right? But actually a bit of it goes into this box. So the way you solve that problem is really we should probably make it to the point where it's 0.5 pixel, right? But then I guess you'd always have this thing where you can land across a boundary. And maybe that's okay, but if you make it 0.5 pixel, it would be... Oh. Yeah, I don't know though. Yeah, but maybe that's okay. I'm not sure though. But let me fiddle with that anyway and see if that fixes the problem. And if not, we can think about it some more. 100! Yes! Episode 100. We've made it. 3 digits. I assume you by hundo. Yes. Let's see. But yeah, it's not the birthday yet. Definitely at hundo though. Yeah, I think we started June 4th. I'm not sure. There was an announcement video. It was then. Whatever's in that one. So it calculates the MIP based on MSB, whatever. So if I up that by 1, that should do what we said, right? Makes it a half size in a way. Right, we're still getting the glitches, and now it doesn't render at all here. Um, right, so something really weird is happening where we're doing a sample and it's failing. Yeah, should we add like a bias? Because it is the depth buffer from the previous frame. So it's kind of like exact. So we add like a bias of I don't know. We did that in the reprojection, right? Oh, there's already a bias. Let's do a bigger bias. Right, still kind of got problems. Specifically on the right hand side. Am I grabbing the... Am I sampling the texture right? Yeah, maybe it's not bias. Hmm. Hmm. We could render occlusion full screen. But it does sample from lower MIPS, so it's not necessarily the best thing to even view, I think. Oh, it doesn't even show. Maybe it's sync code that's the problem there. Okay, let's undo that then. Oh, it's so warm. So if my left or bottom screen bounds box is out of bounds, it doesn't render. That's one problem we can solve. Let's look into that. So is occluded. Is it something to do with this or that? Let's disable that. Right, it's something to do with that function. Yeah, maybe I'm flipping the texture and I shouldn't be flipping the texture. I'm not sure. I think there's one too many flips on the texture. It's something like that and it's reading the wrong. Maybe. Hard to tell these things. So, yeah, I'm not sure what we need to do. Where do we go? Maybe, so the depth buffer, let's start there. So the depth buffer is written into flipped, right? Why do I need to flip the depth buffer? I only flip the screen that we render to. Because the address is bottom left. Sorry, we use bottom left addressing and textures use top left addressing. So we flip it. So if we flip it, so now that it's flipped, so we flip it for when, so it's upside down. And we flip it for this here. So, you know, let's maybe not flip the depth texture. And let's see how that goes. Right, we're clearly seeing the other ball appear now. Right, that's because that's to do with the yeah, maybe that's to do with the debug draw 3D renderer. It's gonna flip the depth here before you read from, the coordinate before you read from it. So we just do the flip here instead. Yeah, so I guess we can just avoid flipping it. It's not going to fix any problem, I don't feel like. Reproject. We don't flip anything in here, no? Right, that's fine. Although, when we do the actual reprojection, we'll need to probably flip it. Or something like that. Yeah, so now when we read the occlusion texture, it's now going to be upside down. So damn occlusion texture, where you at? Is occluded. So we don't want to flip it here. We don't need to flip it anymore. Right, so that could have been a problem because we've got this texture dims. That could be 0. Right. So when it's big, and you get yeah, but it's only when you get one of the highest MIPS. Sorry, highest yeah, MIPS. I don't think that would be a problem. But anyway, we can delete that. That's gone. Right, where's this sort of texture dims at MIP? Where do we use that? Here, good, that can go now. There's just less code that gets ran, at least. Right, so we're still getting this sort of fizzly problem. But now it's shown up at the now the texture's reversed. We could debug rest to see that the texture's actually reversed now. We can debug that debug viewer, we can just flip it there. Oh, for crying out loud. Debug, oh, it's right here. Here, flip. Based on screen dims. Where's that? Here. Alright. I did kind of want it to be at the top. Crap. So I'm going to flip the coordinate and then probably add like this take the size of texture. I think I'm running out of bounds, not gonna lie. It must be at the difference. So that flips it upside down, and you just need to add. It's not that, but it will. Yeah, some do. Maybe we flip the read instead. Yeah, that'd be the way you do it. You flip the read. So where's the read? Source chord. There you go. Source chord. Flip it. There's a source dim somewhere here. Right, so that will mean that the debug view is correct. There you go. So now it's flipped correctly. So we're seeing the same effect in the occlusion buffer there in the debug view. So I think I know why it's glitching. Because we're still rendering too many clusters and the cluster to render array is getting filled up. That's probably it. So the way we can check that is if we do some counters. So does my UI system still work? Well, no, it does still work, right? But I mean, does it render? I think we need to say we need to like alpha blend or something. Here's the render. Right, so this is going to do a UI render. I need to do some UI. Have I got a UI going? Let's see if this still works. Right. So there's some UI somewhere here. UI underscore somewhere. This is some styling. Probably all disabled. Oh no, it's enabled. Where's all this? Oh no, what's disabled is the I don't know. Let's put this on the screen. UI render is running. Oh, you know why it's not working? It's because the rest of the UI system is not enabled, but the render is enabled. So there's like binning and all of this tile binning. That goes on. Why? Right, so here it is, UI tile binning, boom. That was missing. I think that's the only thing that's needed. There we go. Alright, there's my wacky shapes that I'm drawing. And here's some... Right. So there's something to do with the alpha blending. But anyway, we can get some UI that's good at least. Or is it? Should we fix the alpha blending quick? So there's that render code we enabled. So it has some sort of custom SDF rendering virtual machine thing that goes in the shader. So you can do like all these transforms and crazy things like this. It's pretty cool. You can like put a bunch of shapes together and, you know, skew the circle, put another circle down, union them together, and put a border around it. So it's pretty cool. It's pretty over the top, but yeah, that's the way we go sometimes. But anyway, I got rid of that. So this was for the BVH viewer that we did. This is what this UI is here from. But we're going to change that to print out some stats on what we're seeing here to help us debug what's going on. I want to fix this alpha bug though. Like, why is that happening? That's because it's doing a front to back alpha blend. So you can think of, it renders the front first, back, 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 back. So the most front thing is these child left text. Then the background is the shape, right? Then the background of that is the whole render, the whole scene render. But it's not blending against that. So we need to manually put that in. So in the UI render shader, which is this lovely complicated virtual machine, which for some reason is commented out. Did we do 2 versions? I did 2 versions. Oh no, that was a version I used to sort of show an example of how it works. And I had a presentation written up, which I still haven't made a video on. But yeah, one of those. So anyway, at the bottom, we store. But before we store, we need to load. So output. Was ist das, you know? What is that? It's a write only. Read write. So we need to say if it's got any alpha, we'll So it's BGRA as well, so we need to unswizzle it. It's going to be quite easy, I reckon. So here we go. It's kind of heavily optimized, but this shader, because it was kind of like it kind of needed it. So yeah, all fun. So we get this is the background, or this is the sort of game color, right? So that's the pixel. So now you got to do the front to back alpha blend, right? I think I've got a function that I made that does it. Blend pixels front to back. It's this guy. It's pretty neat. So it just does the manual thing that you would set up in the blend modes. That's all it does. So it's pre-multiplied source. I'll pre-multiply the source alpha. Okay. Right, so we've got front and back. All good. So, what we need to do, if I just figure out how to get back to where I was. Right. So this is your background. And the final color is the foreground. So the final color goes in. Game color goes there. Now this would be your final color. And that should be, if we get it right, flip the coordinate, grab it out. Yep. Oh, I need to BGRA the thing. Wait, so it's in BGRA. Do I need to BGRA it again? So I've written it in as BGRA, like this, right? So to get it back out, I need B in R. I think it's the same way around. Yeah, I think so. Yeah. Right, so that should be it. Crap. uint32 is not implicitly cast to... Right, so uint, I need to unpack. Unpack u8 times 4. This function could be written better, I think, but anyway. Alright, it works. Okay. There we go, look at that. Alpha blended. Oh, isn't that great? So now the UI actually sits on top nicely. So the thing we need to work on next is we need to get stats back from the GPU. So we'll have, we need cluster, number of clusters that we can render in a frame, number of clusters. So we need probably the following sort of stats, right? We need the number of, we need the clusters to render capacity. This already exists. That's a constant. But then we need the number of clusters to render count, which is the amount that actually gets rendered out. We also need the clusters cold count. How many did we call? And how many we cold? Yes. We might want to know some other things like how many clusters did we visit, right? How many clusters? Anyway, but yeah, then we probably want to add another level to it where we poll the spheres as well. But we basically need these two bits of information to come back from the GPU, and we can then display on the screen the next frame. So yes, right. And then we can probably tell then with that information that this here is probably, you know, we can just up the number. Yeah, maybe we need to know like how many it's culling successfully. That's a good thing to know as well. Shared, where is it at? Ooh. Clusters. Full volumes. Full instances to render. This is maximum instances we could render if we're completely full with. I'm not even using it. I am. Max volume clusters to render. Yeah. So if I up this to let's up this to 128. Hopefully got enough memory still. Right, we're still getting glitches. There's probably the tile binning. There's a tile binning as well, I think. Wait. Yeah, so it's for the spheres. This is other stats we want. Spheres capacity, where is it? Yeah, spheres cap. Right, I did kind of make it 2 million. Yeah. So 2.5 million, does that fix the problem? No, it's still kind of glitching. So it's not running 2.5. It's over allocating in the tiles or something like this. Maybe. But yeah, it's hard to know exactly. But yeah, we need to get some stats. We need to see like you know, we need to get some stats and fix that issue there. When we move, you see it's buggy. That's just because we're using the depth buffer from the previous frame as the occlusion buffer. So it has some problems. If you move left and right as well, you will get some glitches that will appear. But yeah, so we noticed that it does a really good job up close at culling because the sphere ray tracer tiled at the bottom left, that's 0.5 milliseconds. And that would be like 2. So it really is saving time. But as we move away and a lot of spheres get binned into the same cluster, if you will, it's taken a lot of time. But also as well, this should have probably selected a lower LOD now. Probably. So something, yeah, there's things to look into. Yeah, so we want to get to this to a place where we can sort of gauge how much performance we're saving, or and how many instances we can sort of get in the scene with this running. And then with this we can gauge whether this is the method we want to use for rendering. The other method to compare it against is the BVH. There's a models plan which I wrote. And I did a test. Oh, there's some... Where's it gone? Maybe I deleted it. Oh, damn it. Yeah, this is the plan. Oh, here it is. Ooh. Milliseconds? No. The old plan. 64. No, okay. So the old performance data is not there, probably because I thought it's not good data. But yeah, so we've got this sort of a plan of what we want the system to do over all the features we want and how, yeah. So the other method we want to try is the BVH because we're going to want to do some sort of lighting anyway. So we're going to need, like, this acceleration structure is really great at the primary rays that shoot from the screen and ray trace against the objects. That's what we're trying to accelerate here, is make an acceleration structure that is good at the primary rays and cutting down time there, because that's where you got a lot of pixels. But I think for everything else we want to use a BVH. That's the current plan, but maybe maybe the BVH is good enough. I think when I wrote one last time, it was 6 milliseconds, which was crazy. But maybe I could write a better version next time I do it, because we have a cluster tree now of LODs. Hey Sully, how's it going? How you doing? Right, so I think that's good progress today. We can get some metrics next stream and improve the occlusion texture, occlusion culling stuff. Next stream will be Sunday at 6 p.m. GMT plus 1. Let's find someone to raid. Right, let's raid Artie. Artie's doing some custom engine work. Who's the man? Right, so have a good weekend, everyone. I'll see you all on Sunday. And yeah, thank you all for coming. Appreciate it. Have a good one. Catch you later.